Hi everybody, Steve from Steve's Makerspace. In this video, I'll be going over how I made String Theory, the project you're seeing right now. I'll start with an overview of the project and then we'll get into p5.js and I'll break down the algorithms I used, starting with some simple examples that I'll be sharing with you, and then we'll finish by looking at the final code. This was the first time I released a project using the Ethereum blockchain and the first time using the Artgene platform to sell my art. At some point I'll do a video talking about Ethereum and different platforms, but today we'll just focus on the art. I started the project with trying to emulate the work of Jackson Pollock, seen here. You might call Pollock an early generative artist because he let go of some control over the paint, allowing randomness to play a part. He laid his canvas flat on the ground and dripped house paint from a brush or a stick about a foot or two off the ground. He used fluid motions of his entire body like he was dancing, and sometimes he'd fling the paint onto the canvas. To help me build the algorithm, I read about his technique and watched videos of him in action. I'll leave a couple of links in the video description. String theory puts down shapes in layers, and I show the layering when you run the program. There are 32 color palettes. There are different line angle starts, so it can be straight lines or cross-hatching or totally random. There are different form types. There are transparent or solid lines. There's whether the lines have an outline or no outline or this wormy outline. And there's the possibility of adding a paper texture at the end or not. It always ends with a grain shader. That shader code is by Pagurek and Gorilla Sun. So if we start to look at the code, one of the first things that happens is it loads the color table. I've talked about having a CSV table many times in other videos. I've got 32 color palettes of 7 colors each. Each line represents one color palette. There are 7 colors in each palette, and each one has a hue, saturation, and brightness. The first 2 colors in the palette are for the background, so they have a low saturation. The final color in the color palette is an accent color, so that's usually added last. One of the important things with NFT art is reproducibility at different sizes, so that no matter how big the canvas is, the screen is, the art looks the same. Now, I've talked about this in this video, but for this project I'm using meandering lines that are using Git on a buffer canvas, and I found that when the direction of a line has to be determined by getting something from a buffer canvas, there are often errors in reproducibility, unfortunately. And that was happening with this project, so I decided to draw the art on a buffer canvas and make that buffer canvas really big so that that is what's going to be saved when the user hits S. They can't make it super large, like put it on the side of a building, but they get a 6,000 by 4,500 pixel canvas, which should be suitable for framing. And then I'm using this algorithm here for resizing and placing the image of that canvas onto the available screen space that you're currently using. So I talked about that technique in the beginning of this video. Sometimes with my art, I'll do the entire art in the setup and completely ignore the draw function. But for this one, I wanted to show the user the layering of the canvas, and so I used the draw function to show that layering. So this is animating the process. I talked about animating a process in this video. So some of the functions here, there's a big blob function, there's blank spots function, a make lines function, a make dots function, and then there's apply grain function, and then down here is a paper texture function. And several of these functions are called multiple times for different layers. So I'll show you here. We start with making big blobs in step 0. There's also a blank spots function that gets called. I'll show you that later. Then we are going to make the first set of lines, and those sets of lines are going to be really thick lines. Then step 2, we're going to make our dots. Those are big dots like this. Then step 3, we make some more lines. These are going to be smaller lines. Then we're going to make some more dots. These are smaller dots. There's those. Now we're going to make some big blobs again, and we're going to apply some grain. So here is big blobs and applying grain. It's kind of subtle, so it's hard to see. Then we're going to make some more lines. These are smaller lines. We're at step 6 here. Now step 7, we're going to make some more tiny dots. Then we have the option of adding some paper texture. That is the final step. Let me see. Yeah, this one has paper texture added. Now I'm going to show you some of these algorithms with some simple examples. You can see those links in the video description. This one is blank spots algorithm. And very simply, if I hit start, you'll see different blank spots. This is on the buffer canvas, and this is determining where lines and dots are going to be drawn or not drawn. So I've got it set up to draw in the white areas and don't draw in the black areas. There's a possibility of a blob. This is a very rough Perlin noise field. Then there are stripes, which you can see different types of stripes. There is possibility of an ellipse with a hole in it. And the hole is in a thirds position. It's 1/3 of the way from the right or left of the canvas, 1/3 of the way from the top or bottom of the canvas. Then there's 2 circles is another option. Both of these circles are at a thirds position. I'm doing a thirds position because it's pleasing to the eye. There's a possibility of 3 circles. The large circle is in a thirds position. The other 2 circles I just eyeballed to try to get them to look nice. Next is a full circle. Then there is a full canvas, so just taking up the entire canvas. And then the last one is a very rare type, which is an eye. And this is just 2 curved vertexes and 2 circles to make the eye. So that is the blank spots buffer canvas determining the overall shape of the particular art piece. Next we have blobs and dots. And blobs and dots are almost the same thing. They're virtually identical. And a blob or a dot is just a wonky circle. When you make a circle, if you're not using the circle algorithm in p5.js, but you're actually drawing all the dots of the circle or the curved vertex points of the circle, you use x equals cosine of an angle times the radius of the circle, and then y is the sine of that angle times the radius of the circle. If I made the radius a constant length, then you'd always see a perfect circle or almost perfect circle. But what I'm doing is, as I'm going around the points of the circle, I am changing the radius. It either increases or decreases. And as I get towards the end, it doesn't look at every single point, not 360 points, but it skips some. And it's doing a curved vertex, so it's okay if it skips a little because it's going to draw a curve between each of those points. When it gets to 270 degrees around the circle, or pi times 1.5, then it's got to start getting closer to the beginning radius, because otherwise, if I just continue on changing the radius, then when I get right near the end, you're going to see a jagged edge, basically, because the starting radius and the ending radius are going to be completely different. So what I'm doing when I get to here is I start getting closer to the starting radius. So that's what I'm doing here. If I, which is my angle, I don't know why I used I probably should have used A and G to make it more obvious. But when the angle is greater than pi times 1.5, then I use this formula to get my radius to get closer to the starting radius. So, and then the dots are basically the same thing. They're just smaller than the blobs. So if you can see that, we'll just hit start again. You can see little dots. main thing that's different is we've got a size increment for the dots. So I can do size increment 10 and you'll see larger dots. And all this is doing is when it comes up with the initial radius, the starting radius, it multiplies what it was getting before times the size increment. If we start with 1, that's the tiniest dot. We could go up to 20 maybe, and we get some large dots, which are basically the same thing as the blobs. So now let's talk about the meandering lines. So I've got this meandering lines code, and this is kind of the heart of the program. So I create my canvas and I call the blank spots algorithm, which is going to determine the overall shape of this. So in the blank spots, I've just got a circle being drawn. So if we were to just show that, you would see just that circle, right? And I could change this to a rectangle, and you would see this, and this is actually a square. And so now if I comment this image out, you'll see that the lines are now taking the shape of that square. So with this, the line is going to start somewhere and then it's going to wander back and forth. And we've got an angle variance, which is determining how much that line is going to wander. Is it going to wander a lot, or is it going to wander only a little bit? So if I change this to 0.2, you would see the lines really meandering a lot. That actually looks pretty cool, but we want smoother variances, so we'll change that so that the lines are meandering less. The edge buff or edge buffer is how close are we going to get to the edge, to the area that we don't want to draw in, before it starts to turn away from that edge. And then the line length is for each line segment, how long is that line segment going to be. So then we call the make lines function, and we're going to draw 30,000 line segments. And I've got a scale here of 1. So I could change this to only 3,000 line segments and you get this. And I could change the stroke weight scale to 10 and you would get really thick lines. So we'll put that back to 30,001. So let's look at the algorithm for make lines. So first it's going to call a new line function. Let's go look at that. So we got new line function. The first thing it's going to do is call a new XY position function. So we'll go look at that. And the new XY position is picking an X and picking a Y from the canvas, random position, and it's going to check that random position to see if it's allowed to draw in that position. Because remember, you're going to have these different shapes, and we don't know whether we can draw in that shape spot or not yet. So we're going to get from the buffer canvas the XY position, and then we're going to check that position to see what color is that pixel in that spot on the buffer canvas. And if that spot is black, then we're going to break. We're not going to continue trying to draw on that XY position. We're only going to draw on that XY position if it's white. So let's say we're safe to draw in this position. Now we come back to the new line, and now we're going to pick an angle. So here we're picking a random angle to start the line with. And then we're going to pick a random starting stroke weight, and we're also going to call X previous X and Y previous Y, which I'll get to in a minute. So we've got our new line started. We'll come back up to the make lines. And now we're going to start making the number of segments that we called. We called 30,000 segments. First, we're going to take that angle that we started with, and we're going to add or subtract more or less angle, basically. And then we have to calculate where the new line is going to be. So we've got a line length. We have a new angle, and we can use sine and cosine to calculate where the new X and the new Y are going to be. So we have our new X and our new Y. but I want to see, am I approaching an area where I shouldn't be drawing in? So I'm going to call the edges function, and it's going to check in front of the line. It's going to go a little farther out, looking ahead to see, is there a black area where I shouldn't be drawing in ahead of me? And if it does have a black area ahead of me, then we're going to change that angle. So we're adding a turn to that angle. It's going to take a left. So we come back here, and we've either taken a left or we haven't taken a left. Doesn't matter. The next step is we're going to change the stroke weight of that line. We're going to either increase it a little bit or decrease it a little bit. And then we're going to constrain that stroke weight so that the line doesn't get too thin and it doesn't get too thick. And now we're finally going to do the stroke weight of the line, and you see we're doing this SW times SW scale. So if I'd put the scale up to 10, then we'd just be taking that stroke weight and multiplying it by 10. So now we finally draw our line. We're drawing our line from the previous X, Y to the current X, Y, and then we name the current X, Y position the previous X, Y position, because we're going to be calculating a new X, Y in the next go around. So we want to know where our starting position is for our previous X, previous Y. There's also in here a random chance that we'll just start a new line. And I could increase this random chance of starting a new line to 10, and you'll see a lot more lines being started. Or I could make it 100 and probably just see a bunch of dots. So let's do this. Let's layer these. Instead of 30,000 at scale 1, let's do 10,000 at scale 20. And we get some nice thick lines. Actually, let's lower that to 15. There we go. And now we're going to do a different color. We're going to layer in some more lines at a somewhat smaller stroke weight. So scale of 5. Let's do another color with another layer of lines. These ones are kind of a purple color at scale 1. Now, remember there are different starting angle. We can have a random starting angle, which is what this is. The other option is let's do a starting angle that is constant. All the starting angles are going like this. And I could change this to pi times 0.5. And now all the starting angles, let's hit start a few times. Yeah, they're all starting going this way. The other option is a crosshatch. So let me uncomment all of this. So it's doing a random chance, 50% chance that will start like this, and a 50% chance that will start like this. So that creates a crosshatch. So that is basically how this works. So now let's go back to the original code. Unfortunately, I am not going to be sharing the final code with you because I have been burned several times with people doing copy minting on me. And I'm kind of tired of it. I've shown you the concepts, and I'm going to go through some of the other details in this code, but I've shown you most of what is happening with this code. So one of the things we haven't talked about is the possibility of having an outline for the lines. So if I do 0, some of these outlines are hard to see because they're gray color. There's a possibility of from 0 to 50 gray color. There's the possibility that there's no outline. There's a possibility that there is an outline, and there's a possibility of these worm segment outlines. There we go. You can see it with that one. Worm outlines. But most of the outlines don't have that worm thing going on. For the make dots function, if there's not supposed to be an outline, then we just do no stroke. And if there is going to be an outline, then we just do stroke. So that's pretty simple. But for the make lines function, it's more complicated because we're drawing lines and you can't really do an outline for a line. You could try doing rectangles, but if you did rectangles, then you'd have to push translate, rotate, pop, and that's a lot of extra calculations. So what I'm doing instead is I'm drawing two line segments every time. So for the worms, I can just draw, say, a black line that is a little bit thicker, and then another line that's going to be the colored line a little bit thinner. So that'll look like it has an outline to the colored line. If I just do that on the regular canvas, then that's going to be the worm effect, because every line segment is going to have an outline. But if I want the entire line to be outlined, then I need to draw the entire line black and then thicker, and then the entire line colored and a little bit thinner. So in order to do that, for this step in the algorithm, say I'm going to be drawing all the thick lines, I'm going to draw all of the thick lines on one canvas, on the main canvas. I'm going to draw all of the thick lines on this buffer canvas that I'm going to create. And then when I'm done with both of these, with the algorithm, I'm going to take the colored line canvas and place it on top of the canvas that has the black lines. And that's how I get the outline of my lines. Okay, a little bit more detail in here. This is the edges. Besides looking at the front, just looking straight ahead, I'm also looking to the right and to the left. That is in case I'm getting into a corner. I want to be able to just stop and start a new line if I'm really cornering myself. The other thing is for the turning. I'm turning to the left on that example that I showed you, but I want to be able to turn both ways, left or right. So I've got a random chance, 1 in 150 times, that I'm going to change the way I turn. Turn starts by being 0.2, which is just an angle. And if it's going to turn, it's going to do angle plus equal turn. So it starts off turning to the left. Then at some point it switches, and now it's doing angle plus equal negative 0.2. So it starts turning to the right. So I think that's basically it. There is the grain shader. I've shown that before. This is Dave Pagurek and Gorilla Sun made this grain shader. This is where I determine the amount of noise. I'm doing a little less than 10%. So that's basically it. That's how the string theory art project works. I hope you enjoyed this video and you got something out of it. If you liked the video, please give it a like. Consider subscribing to the channel. Ring the bell for notifications. Comments are always welcome. I love to read your comments. Thanks for watching. I'll see you in the next one. Bye now. Steve's Makerspace.